Hello everyone, we are from group 9 and we has 3 members. There is Nur Afina Fitriyah binti Hasmuni, Nur Adriana Syafiqah binti Sani and Nurul Hanan binti Muhayyidin. In this video, we are going to talk about related reads and the applications of differentiation. Let's start with the introduction from Afina.
What is differentiation? Differentiation in mathematics process of finding the derivative or rate of change of a function. In contrast to abstract nature of the theory behind it, the practical technique of differentiation can be carried out by purely algebraic manipulations using 3 basic derivatives, 4 rules of operation, and a knowledge of how to manipulate functions. What is related rates? Related rates involve 2 or more variables that change at the same time, possibly at different times. If we know the variables are related, now how fast one of them is changing, then we can figure out how fast the other one is changing. This usually involves writing an equation relating the 2 variables and taking the derivative of the equation with respect to the time.
Let's see the problem statement from Adriana. Let's see and answer a question. An airplane flying at 450 km per hour at a constant altitude of 5 km is approaching a camera mounted on the ground. Let theta be the angle of elevation above the ground at which the camera is pointed. When theta is equal to pi over 3, how fast does the camera have to rotate in order to keep the plane in view? There is a way to determine the differentiation by several steps. The first step is to draw a diagram to facilitate our work of understanding the intent of the equation. The second step is to list all the variables and value given in the equation to identify the values to be searched for. The third step is to find the derivative values. Take the derivative with respect to time of both sides of the equation. The last step is, after finding the derivative value, solve the problem and enter all the values into each variable to find the value we are looking for. Let's solve the question. To solving the question, we need to sketch the diagram first. After sketch the diagram, we need to list down all the variables given in the equation. In the equation, it is given 450 km/h, where 450 km is the derivative distance, which is dx over dt. But we must be careful that 450 is a negative value because the plane moved to the right, that is closer to the camera, and this shows that the distance between the plane and the camera is decreasing. Therefore, the derivative value is negative value, which is negative 450, while its height is 5 km and theta is equal to pi over 3. The question asks us to find the derivative of theta, which is theta is with respect to time. To find the derivative of theta, we can use the formula Soh-Kah-Tua. Use the tangent theta equal to 5 over x. From here, we can find the derivative of the tangent theta by doing differentiation of both sides, and the derivative of the tangent theta is the tangent theta d theta over dt equal to 5x dx over dt. From the tangent theta d theta over dt, we need to convert the tangent to the derivative of the tangent, which is the derivative of tangent is secant squared. While for x, we can take x go up and it will be changed the 5 over x to 5x to the power of negative 1. And to find the derivative of 5x to the power of negative 1, we need to use the chain rule to find the derivative of 5x to the power of negative 1, and from that we will get 5x to the power of negative 2, and then convert the secant square to 1 over cos square theta using a trigonometric identity. Next, we need to find the value of x, where we can find it from the tangent theta equal to 5 over x. To find the value of tangent theta, we need to insert theta with the theta value given in the equation, which is theta is equal to pi over 3. Then we will find the value of the tangent pi over theta using trigonometric identity. And then we get the value of x equal to 5 sec 3. After getting the value of x, insert all the value to find the derivative of theta, which is d theta over dt. Insert the value of 1 over cos squared theta times d theta over dt equal to negative 5 over x squared times dx over dt. From that, insert the cos squared theta with pi over 3, and we will get the value of cos squared pi over 3 is 1 over 2 by using the trigonometric identity. For negative 5 over x squared, insert the value of x that we get from the solution we do before is 5 over sec 3 times with dx over dt. And we know that The value of derivative of x is negative 450. Insert all the value and solve the question. And the answer for the question is 67.5 radian per hour. Now, let's go to the conclusion by Nurul Hanan.
Conclusion. To help us solving the related rate question in a better way, when reading the question, read carefully and slowly to fully understand it. When we understand the question, we can imagine it and try to figure it out by drawing or sketching it as mentioned. Take note every important information that already given in the question. This information will help us in the calculation process. Besides that, we also need to know and remember formulas for geometric shapes, ratios such as the Pythagorean theorem, area and volume formulas, and also triangle identities. Related rate question, usually easier to use the chain rule, but not every question need to use chain rule. There are questions that can be solved by using the product rule, implicit differentiation, quotient rule, and others. Lastly, there are many applications of related rate in our daily life and in a certain career. So, it is very important for us to understand this topic and know how to solve it.
That's all from us. Until next time, thank you.